By the end of these 30 minutes, you're going to be able to hit Steam's API endpoints and get your game's latest news directly in front of players inside of your game. By popular vote, hitting an API endpoint took the win. So today I'm going to be showing you an example of how to hit specifically the Steam API for getting news. But generally this is going to be applicable to most APIs that you're hitting. There may be some tweaks you need to make here or there. But let's go ahead and get started. So I've got on my other screen here my code because it is quite complex, but just I want to walk y'all through it to make sure it's pretty easy to follow along. First thing we're going to need to do is we're going to need to create an actual C++ class for us to hit this endpoint, of course, because this is our C++ series. But to make a blueprint node that's easy to reuse, we're going to do some things here. So first thing we're going to do is I've created a basic HUD to actually use for displaying the text that we get back. But what we're going to want to do is go ahead and go in here and create our new C++ class. Oh, sorry. If we go in here and create our new C++ class. Now, this is specifically going to need to be an asynchronous class. So that in Unreal Engine, we have something called the blueprint. If I can spell correctly, AsyncActionBase. So basically, there's a few things you can do with this, but the nice thing is this allows you to asynchronously hit those endpoints and get that information back in a way that's a bit more user-friendly for yourself. So we'll go ahead and create it, and what we're going to call this is going to be our, you can kind of call it whatever, but I'm going to call this my JSON API caller. So that's what it's going to do. It's going to hit APIs with JSON data and be able to do things with that JSON. All right, looks like the live coding built, so we should be good to go into our project, and we're going to hit reload all, and of course it's going to pull in those new classes. So when it pulls it in, it's going to be very blank, not a whole lot going on here. So let me go ahead and close some things here, and we'll get looking at our code here. So to start off with, we're going to need to include a few things. Now, these are just sort of the basics of what I have done with my code. Let me actually do this. All right, there we go. And then we're going to put this all in here. All right, so kind of talk about them, what they are. Of course, you got your core minimal. We've grabbed the engine, and then we've got Kismet that came with it. Then we have Delegate, HTTP, and JSON. So these ones here, so the engine and the delegates here, these are going to give us access to a couple of things. To hit an endpoint, we're going to need the include of the HTTP, and that's going to allow us to actually reach out to the web and say, hey, here is the link that I'm hitting. Now the JSON is going to give us the ability to parse JSON, so we can actually inside of our reader here, we're going to need to be able to have a JSON reader factory and things like that. We'll go a little bit more in detail on what those are and what those mean. But there's just a lot of JSON things that we're going to need to be able to do to actually parse the data that we get. So let's go ahead and start off with our first function so we can kind of dive into what we need to do here. So the first thing we're going to need to do is actually make a delegate. So to make this asynchronous, you need to include a dynamic multicast delegate, basically so that the engine can listen for the return. So what we're going to do here is I'm going to grab this, we're going to walk through what that code looks like. And so as you can see here, we have declare dynamic multicast delegate to params. Now there are a variety of different versions of this. So you can have 1 param, 2 param. I think there's even up to 3. I think beyond that, there are a few other things you can do instead. Yeah, okay, no, it's up to 9 params. Beyond that, there's a few additional things you can do, but that's just what comes with the engine by default in terms of the macros that you can access. And so what we're doing here is we've got a little bit of code here. So we got this fcall completed. This is basically our our actual blueprint assignable callback. So we go into our blueprint when we're done with all the code and everything. We're going to have the ability to say when this is completed, or call completed, as you can see here. And this is the delegate that's actually being called. So this is what actually tells it, hey, I've gotten information back. Here's what I've received. Then over here we have a const array of f strings. Basically, this is the title and content. This is the returned information from that endpoint. So as you can see here, this addressable symbol, for those of you who are not necessarily very familiar with Unreal Engine and C++ in general, basically for the purposes of the reflection system, by having this address symbol here, it's basically telling the engine, hey, this is what I'm going to receive. I'm going to receive some kind of array of strings, and I'm going to call it title. And the function, the delegate, is going to return to the blueprint side the array of strings called title. It's also going to return an array of strings called content. And what that's going to do is, as we fill it out below, this basically going to pass to the blueprint side all of the information it needs to know what to do with. So for example, it's going to pass from whatever we receive from Steam to the front side. Now, of course, this needs to be modified based on what endpoint you're hitting, what you're expecting it to return, because of course different endpoints are going to return different information. Anything you don't need, though, you don't technically need to include. I believe if you just don't have it included here as one of the params, it just won't be included in there. All right, so let's go ahead then and move on. We're going to talk about our actual functions here. So first we're going to create a little public section. This is for anything that we're going to actually be able to access inside of the blueprint system. I like to keep it under public because it keeps everything all together. Now what we're going to need is a U function. As you can see here, we'll hit that. And this is going to be blueprint callable. And it's going to be of the, you can give it whatever category you want. I'm going to just give it the category of Steam. That way it's a little easier to search for it. I guess technically I could call it Steam News. That way it's a little easier to look up when we're going through the search bar. From here, we're going to add actually some meta tags. Now, meta tags can provide a very useful way for blueprints to know what's actually going on with this specific item, what call needs to be made. And so for this is actually going to need the blueprint internal use only. So basically this means that this is implemented in another function or node, but it's actually not exposed to the blueprint class. Now the reason why we want that to be blueprint callable but in blueprint internal use only is sometimes you can get a cascading effect where a function you're calling that is blueprint callable and doesn't have that meta internal use only needs to call to this URL function. So you want to make sure that they're cascading correctly in terms of permissions. So that's why it's part of the meta tags rather than the base tags. Blueprint internal use only equals true. And then what we need to add here is a world context. Now, the reason why we need to add the world context is kind of twofold. Basically, when the call is made out, Unreal Engine needs to know which world it needs to send the information back to. Because ideally, in theory, you could have multiple worlds going simultaneously. Especially in multiplayer environments, you can get very weird things where the information is sent to the wrong world context object, and you'll end up displaying the news information, especially if you're displaying in a more dynamic way, in the wrong screen. So let's say the player goes to the main menu and it takes a second for the API to load. They go to another page, or they go into a world, and you accidentally display that news right in front of them when they're in the wrong place for that. So by doing the world context object, to make sure that it's sending it to the correct place and not incorrectly sending it elsewhere. So now that we've got our U function specifiers created. Now we actually need to create the function itself. So this is going to be a static, and this is a specific type of return value here. So it's a UJSON API. Sorry, I misspoke there a little bit. This is the name of the class. So we're basically pointing to saying, hey, this action base, this is a pointer to that. And this is going to be our URL. This is the internal function here. So it's a U object. So this needs to have a U object. And it's going to be a pointer, of course, to the world context object. And then we need an F string. And this is going to be the past URL. All right. So what that's going to do is this is going to take in a past URL, and it's going to take in a world context object, and then it's going to make the call. Now, let me go ahead and hit create definition. And it's going to create the definition in the CPP. Now what we need is we also need to be able to have a blueprint assignable delegate call. So we're going to create a U property. There we go. And this one is going to be blueprint assignable. And don't worry if this is all very complicated, because it definitely was to me when I first started doing this kind of stuff. It is something that is very complicated when you are working on it for the first time, but it starts to make more sense the more you call these endpoints and the more you work on these. It's one of those things where it's, there we go, call completed. The more you do these kind of functions, the easier it gets. Now, as you can see here, we have this fcall completed and call completed. Basically, these are our blueprint assignable U properties that are going to be referenced here by this delegate. Now, in the actual CPP file, we're going to use this to actually broadcast. But for now, we're just having it here as part of the actual class itself. And then we need our virtual void, and that is going to be activate, because we need to override this. Override. And then we need the actual internal function. So basically that URL, the URL function up here, right? We're going to call this, and it's going to be calling to this make the request. And that's just the name of the function. You can call that whatever you want, but that's just what I call it. So HTTP, and we need a request pointer. There we go, request pointer. And we'll just call this our request. And then we need a request. There we go. Sorry, not request. We need a response pointer. So this is basically what we get back from the actual endpoint that we've hit. We're going to call that response. And then we need a bool. And this bool is going to be our connected successfully. This basically just tells the system, hey, did we get a successful message back? Because APIs can return a lot of different error messages, and I could be including an error message here, sort of saying, hey, what message did you get back? Because then even if it doesn't connect successfully, sometimes you can get error messages back that are useful for telling you, oh, hey, you need to be behind a certain VPN, or you need the correct API key, whatever that error message actually contains. All right. Now that we've got that, we need to create a couple of private variables here. So we're going to go ahead and create a private section. And these are going to be two things. One is going to be a world context object. Now this one, we're going to put the eProperty title here just in case we want to do some stuff with it later. But technically, with it being in the private, it is technically a private member variable. World context. Trying to make sure I'm getting this all correct for you here. All right. then we have an F string called m_URL. All right, with that, we're going to create some definitions for these. And create definition. One thing you'll see here is it's going to say we can't find this class of fcall completed, but we're going to get that hopefully fixed here in the CPP file. So we'll go ahead and hit save and come over here. Now we've got a couple of things we need to do. We're going to start all the way back at the activate because this is sort of the when this class is activated, when things are called, here's what we want to happen. So of course we need to call our super and call active. Wait, if I can spell today. Oh, yeah, activate. Okay, okay, that should be correct. I'm not sure why. Sometimes it will show an error until you get a little bit more code in here. All right, now here is where we're going to get our world context object. This is why we needed the engine include. So this is going to be G engine. And then we're going to get in and go get world from context object. Oh, sorry. It's get world from context object. Oh, well, it won't let me prefill. So get world from context object checked. This is the one we want because specifically what this is going to do is it's going to actually assert if it can or can't be found. Because we want to make sure that if a world context object can't be found, we of course don't want to actually be making the call because it should only be making with a world context object valid. All right, and then we're going to actually create our actual request string. So we need to create an FTTP request. Believe specifically we need a request ref. And this is going to be called request equals FHTTP. This needs the module manager. We're going to call get create, I believe. Yeah, create request. And now what we're going to do is we're going to actually pass into the request object a few things. So we're going to say on processing request complete. We're going to bind lambda. So basically we're telling it, hey, when you've completed, here's what we want to do. So when you get information back from whatever API you're hitting, here's what we want to do. So we need to pass in this. And then it's going to be the FHTTP. And it's a request pointer. Request pointer specifically. Because basically, in fact, we can actually copy, because this is basically modeling this make the request here. So what we're saying to this on process completed, we're saying, hey, when you complete this request, we've got this function we want you to run, and it's going to be this, and then here's the details of what you need to actually run. And then with that, we're going to jump down here, and here's the actual function we want you to run, and we're going to say make the request, and then from there we pass in, of course, to our request, our response, and our B was successful. Oh yeah, because technically this was successful. This I renamed slightly differently just to make it a little bit more clear in my own code as to what's actually going on here. So what's going to happen is it's going to make this call. It's going to say, hey, here's the information that we're expecting back. Make this function call with this information. So it passes in a bool, passes in a response pointer and a request pointer. And then from here, that is the closing argument there. Now what we need to do is actually in the request, pass in a little bit of information. So we need to set the URL. So where is this actually reaching out to? And that's going to be our m_URL, which we haven't yet set that variable, but we're going to in just a little bit. And then our request, we need to set verb. So the verb is your action, right? That's your get, post, put, whatever your actual action is. For this one specifically, we're doing get. You could create this as a variable and include it as part of your function call. For now, this is just a way to get the API. If you want to push, post, whatever, you need to have a little bit more details, but it's basically the same setup, but just slightly tweaked. And then from here, request, then we're actually going to call on the request, process request. And what this will do is when this code is called, it's going to go through here. It's going to set up the request. It's going to set the bind lambda. It's going to set the URL, set the verb, and then it's going to go, all right, now make the request. And then from there, we need to make the request. Now this is going to be a little bit complicated, so I'm going to grab some of the code and then we're going to walk through it just because there's an awful lot to type here. But essentially we start, let me save, so it should hopefully update there. So at the top, we have an array of f strings called titles and then an array of f strings called content. Basically, this is our expected returned items. Of course, depending on what API you're hitting, you want to make sure that you have the correct information based on that. Then from there, we create a pointer to the to hold the JSON serialized data. So we grab a shared pointer to the entire JSON object and just call it JSON object. From there, we need to actually create a reader pointer to actually read that data out. So this is a shared ref to a JSON reader, and we can just call it reader. And then we create a JSON factory with the response get content as string. So basically that's going to pull in the entire JSON object and it's going to turn it into a string. And that is so that we can break that down into chunks and get the different pieces we need out. From there, we deserialize it basically to actually make it so that we can pull the information out. So we do fjson serializer, deserialize, and then we pass in our reader, that factory we created, and the JSON object. From here, we then take a pointer, shared pointer to the fjson object, and then we call this app news, and this is a JSON object that is, we're getting a specific object field. So we've taken our JSON object, we've created a reader that's actually a string version of it, and then we're going in and we're actually getting the object field out of the base object so that we have access to the object that's in there, and then we're also getting an array of shared pointers of the JSON value that are getting the array field news items. So essentially we're going in, we've got this big JSON object, we've broken it down, deserialized it, and we're going in and we're pulling out the parts we need. So we need the app news, which is just a object field, and then we need the array field, which is an array within that object called news items. From there, we're going through every single item in that array, and we're saying, all right, we're going to create an fjson object shared pointer, and we're going to set that to the array index as the object. Now from here, you can do some things like get string field names, and I did some logging and stuff just to make sure everything was working. But the actual thing that you need to do is then at the titles and content you need to add. So depending on what API you're hitting, I'll determine what you're actually adding. But here's an example with titles. I'm just doing titles.add, and then I'm getting that object that I have a pointer to, and I'm calling get string field, and then I'm asking for the title here specifically. And then I'm doing the same thing for the content, but specifically asking for the contents. Now what that's doing is that's iterating through that array that we created, and it's setting a pointer as that object, and then it's going and looking at that pointer and saying, all right, give me the string field from here that's called title, give me the string field from here that's called contents. Then from there, we just hit up our call completed and broadcast to it titles and content. All right. And then that should be all of that. And we've got our super. One thing that we need to do is one last bit. Here at the actual URL, so this is where the call is initially made, we need to set up a few things before we return them. So we need our JSON caller, and then we need a pointer to our JSON API reader, which is a new object of the type JSON API caller. So this is basically we're creating a reference specifically to the class here. The reason for that is for things like APIs and stuff, you need something that is living in the world to actually make these calls. That's why it activates and things like that. Even though we're doing a lot of statics, we're basically just populating, creating this class, and then making all of the calls. Then from here, we're doing JSON API reader, and we're passing in that world context object, and we're setting it equal to the world context object. And then lastly, this should be JSON API reader, and we're passing in that URL. And we're passing in the past URL. And then we actually want to return our reader here. All right, so that should be pretty much everything here. It is a little bit complicated because there's quite a lot going on here. But let's go ahead and hit save. And from here, we should be able to reload the engine. Just take a look at what this actually returns. All right, one small correction that I had to make. I completely forgot about it. In the actual build files here, down you should see, so we need to actually add the HTTP and JSONs as part of the dependencies. Now that we've actually added those, we should see that should clear up the issues here once we go ahead and start without debugging. All right, now we've gone ahead and actually gotten our system all set up. Let's actually open up our UI here. So we've got a few different things we can do here. So let's go in and what we're going to do is we're just going to add a very simple little text section here. This will be for our news. We'll just, we'll not be too picky on what exactly it looks like because we're just wanting to verify that the API is in fact working. And then from here, we're going to go ahead and grab that text block, and we're going to go into our pre-construct and actually call that. Actually, no, we want it to happen when we load in. So let's actually just go to and create a on construct. And we're actually going to call that URL. So now we can get our Steam news. What we're going to do is we're going to go ahead and pass in the correct URL we need. And then when our call is completed, we're going to actually set the text block. Now, for now, we're not super worried. Oh, that's the wrong one. We're not super worried about specifically what we're passing back because we're mostly just wanting to make sure it's working. So what we'll do is we'll do Ganta and get a copy here of the 01. Now, this is going to be, I'm going to be passing in, the Steam has specifically an app that lets you, an application that lets you test the actual news endpoint. So let's go ahead and come back here and we're going to grab the link. So in case you want this, this will be included in the description below. But what we're going to do is we're going to pass in the URL here. As you can see, this is api.steampowered.com /iSteamNews /get news for app /v0002. The app ID is 440. That's one of Steam's testing apps, and we're calling back 3 possible news sections with a max length of 300, and we're going to format it to JSON. So now all these arguments are passed in. What we should get back is a little bit of text from the endpoint. As you can see, now that we kind of got that done, we can kind of walk through what that means. So that URL is getting passed in. It's getting passed in here at the top as this pass URL. The world context object is going to get passed in automatically. That's not something you necessarily need to pass in, but that URL, that function, then comes in and goes, okay, create the API caller class, and then let's go ahead and grab the world context object, which is the one being passed in, and then we're going to grab the pass URL and pass that into the API reader. From here, we return the API reader, and what that's doing is it's making this activate here call. So this activate gets called, it grabs the world, and actually this is where the actual world context object gets grabbed. We pass it in here through the pointer because it's part of the required for an active class. We could always do weird things with that, but for now we're just letting it automatically get set here. From here, we make a request to actually create the request. So we're creating the request class. We're making all of our binds and everything here like we talked about before. And we actually make that request. So then from here, this delegate gets called, and this delegate right here, this broadcast call completed, that is what is getting set here. By having the letters capitalized, that's how it knows where to separate it and create that space. But what it's doing is it's saying, hey, create this, call this URL. Once this gets created, then set the text. So we go in here and load up. We'll probably see, there we go. For like a split second there, you could see it say text now. And so a lot of times you'll want to like hide the text box until the text comes in. But you can see it's a Team Fortress 2 update. But yeah, as you see here, there's some stuff we're going on with the project just due to some stuff with the project itself. But yeah, that is the very much basic bare bones of the actual function itself. With this, you can do a few things. For example, this gets executed immediately versus this only gets executed once it returns. So if you know that the API is going to take a while, you might use this pin to do something depending on what you want to do. So for example, right here, if we want to print string and say loading ... we can see how many times that actually gets called until the actual thing returns. So yeah, with this one time, it just gets called the once because it's a pretty fast and quick API. Of course, with slower APIs, you may want to do more. But yeah, that is it for today. If you have any questions, leave them down below. But otherwise, good luck and good hunting.